NODAR sets a new benchmark in point cloud generation, producing over 5 million points per frame. To visualize and analyze this massive amount of data, we've developed NODAR Viewer, an advanced desktop application designed for seamless visualization of 3D data generated by NODAR Hammerhead. NODAR Viewer enables users to connect directly to a running Hammerhead system for real-time data visualization, or to replay recorded datasets. This powerful tool is an essential asset for engineers working with NODAR's high-density point clouds, enabling detailed analysis of algorithm performance. In the View option, you can open or close the Properties window. Alternatively, you can do the same using a shortcut. In the Layouts menu, you can select one of the predefined UI layouts. If I close some windows, I can restore them by selecting the layout I want. The Viewers option lists all available viewers for Hammerhead data. In the Help menu, you can check the current version of NODAR Viewer. It's important to use matching versions of the Viewer and Hammerhead application when using a remote connection. In the Properties panel, you can select the UI font size. You can also choose to connect to a running Hammerhead application or replay a recorded dataset. In this section, we'll talk about data viewers. Each data viewer window has a context-dependent properties panel. Using the Convert button, you can switch the current viewer to another type, toggle full screen mode, or close it. Now I will use a recorded dataset to guide you through all available viewers. To start a playback session, first open the Timeline viewer. Then, select the folder with the recorded data and press the Activate button. Now you can play, pause, and step through individual frames. In the Rectified viewer, you can see a rectified image. In the Properties panel, you can choose between the left and right images. This dataset doesn't have a recorded right image, so nothing happens when I step through frames. The Bird's Eye View viewer shows the scene from above. You can display the image vertically or horizontally. Additionally, you can show or hide the grid and adjust the grid cell size. The next viewer displays a confidence map. It has no configurable properties. The Disparity viewer displays disparity images. Here you can also choose between the left and right images. Since this dataset doesn't include a recorded right image, it is not visible. The Obstacle Tracker viewer displays objects detected by NODAR's GridDetect system. Similar to the Bird's Eye View viewer, it can display images horizontally or vertically and allows you to control grid properties. The Raw viewer displays the raw images from the cameras. This dataset includes both left and right images, allowing us to use two viewers side by side to show images from both cameras simultaneously. The next viewer is the Point Cloud viewer. It displays the generated point cloud data. You can navigate the point cloud using the W, A, S, and D keyboard keys. Use the Q and E keys to move up and down. Holding the left mouse button while moving the mouse will rotate the 3D scene around the pivot point. You can hold the Shift key and use the movement keys for smoother movement. Press Ctrl plus R to reset the camera. These controls are listed in the Properties panel. Now let's go through the different properties of the point cloud viewer. In the View section, you can change the background color. You can also change the camera's projection. Be aware that due to the nature of the orthographic projection, far and close objects will have the same size on the screen, making navigation more difficult. You can also adjust the 3D camera's near and far clipping planes. Additionally, you can show or hide the pivot point and change its position using the UI controls. By the way, holding the Ctrl key and left-clicking on a point will attach the pivot to the selected point. In the points section, you can adjust the point size. You can also enhance the point colors by increasing their contrast. You can assign different color schemes to the point cloud. For example, the solid scheme sets all points to the same color, and you can choose the color you want. The image scheme assigns colors to the points based on a camera image. The next scheme is range, where colors are assigned based on a point's Z position. You can set the minimum and maximum values for the range. The height scheme works similarly to the range scheme, but instead of assigning colors based on the Z position, it uses the Y, vertical position. The grid section allows you to configure various properties of the 3D plane grid. You can turn it on or off, adjust the line width, set the line count, change the spacing, and select the color. In the bounding boxes section, you can choose to display the bounding boxes of detected objects. Here, you can adjust various box properties, such as line width and color. Additionally, you can modify the Y position and height of the boxes. In the blended depth viewer, you can see the camera image combined with depth information. Colors represent the distances to the points. In this viewer, you can left-click on a point to see its distance. This viewer does not have any configurable properties. To deactivate playback, press the Deactivate button. Now, I'll show you how to connect to a remotely running Hammerhead system. Here, I have an NVIDIA Orin device connected to my laptop via a USB cable. First, make sure Hammerhead is running. If it's not already running, start it. Now, start NODAR Viewer and press the Connect button. Keep in mind that your device's IP address may be different. Now, the viewer is connected to the running device and we can see the data live. Some viewers are only available when using a remote connection. Let's take a look at them. With the control viewer, you can pause and resume Hammerhead. You can also instruct Hammerhead to save files to disk. The data will be saved on the running device based on the settings in the configuration file. Additionally, you can reset the calibration and adjust exposure and gain properties. With the initial calibration viewer, you can start the camera calibration process. If you open the Properties panel, you will see 3 different calibration types. For a static scene where objects do not move, you can select Range Calibration. Then, use your mouse to select an area and measure its distance using a device such as a laser distance meter. Enter the measured distance. Once you're ready, press the Submit button to start the calibration process. During this process, Hammerhead will not send data and the viewer will not be updated. With the Recorder viewer, you can save data directly on the machine running the viewer. Select the types of data you want to save. Specify the folder where the data should be stored. Press the Start button to begin recording. Once the data is ready, press the Stop button. Now, you can navigate to the folder to view the saved data. This folder can be used to play back the data later without requiring a running Hammerhead. To disconnect, press the Disconnect button.